all, this is Manisha, faculty of Chemical Engineering Department, JET College of Engineering, Mangalore. Today I am going to discuss about the natural convection type of heat transfer. We all know that the heat transfer is based on three different modes, that is convection, convection and the radiation. Convection type of heat transfer we will observe in the solids, convection type of heat transfer we will observe in the fluids like liquids and gases, and radiation type of heat transfer observed in the waves or radiation. Heat is transferred from higher temperature region to the lower temperature region. This is another example for the convection type of heat transfer. Convection type of heat transfer is nothing but the heat is transferred through the motion of molecule from one region to the another region, that is from higher temperature region to the lower temperature region. Through motion of molecule you can observe. This is again divided into two types, like natural convection and the forced convection. Without using any external agency, heat is transferred from higher region to lower region, that is called as the natural type of convection. By using some external agency like blowers, fans, heat is transferred from one region to the another region, that is called as a forced convection type of heat transfer. To increase the heat transfer rates, to increase the heat transfer coefficient of the particular system, we will prefer the forced convection type of heat transfer. Coming to the experimental parts, this is test pipe, that is a vertical cylinder. For this vertical pipe we are going to calculating the heat transfer coefficient. This is a control panel. Control panel is mainly contain the parts of heater, that is the input to the device, and then this is called as a PID controller. The red color indicates the PV, that is process variable. That means how much temperature is there at particular point of time. Set value is a fixed value to the system. This is mainly for this equipment we can fix from the 50 to 80 degrees centigrade. Here we fix the value to 70 degrees centigrade. So this is a fixed value. This is the maximum value input we will giving to the system. Based on the input we are giving, how heat is transferred from one end to the another end we are going to calculate. So this is about PID controller. This is called as a digital temperature controller. This will display the temperatures of the different points of the test pipe. This is the channel changer to get the temperatures for the different points. Like this is the one that will indicate the temperature of the T1. That is nothing but temperature of the test pipe at first point. Next, if you change the channel, that will change it to T2 temperature. That will indicate the temperature of the second point of the vertical cylinder. Likewise, we can get the temperatures from T1 to T8. T1 to T7 are the surface temperatures of the test pipe. T8 is the ambient temperature. So these are the T1 to T8 temperature that will indicate the temperature of the surface as well as the ambient temperature. This is the basic description of the natural convection type of heat transfer. Coming to the experimental procedure. First, before starting the experiment, we have to take the values for the time t equal to 0, that is nothing but without giving any input to the system. So before switching on the heat, we have to take the values from T1 to T8. Why? Because if you know the value of the initial, then only we can observe how heat is transferred from the time being. For first 1 minute, how the temperatures are changing. Next 1 minute, how temperatures are changing. Based on that, we can calculate the heat transfer coefficient of the test pipe. So first we have to take the initial values of the test pipe as well as the ambient temperature at time t equal to 0. So we have to note it down as time t equal to 0 from T1 to T8. Then we have to switch on the heater. Then immediately heat is getting started. This is the heater at the one end of the test pipe. Whenever we are switch on the heater, immediately heat is transferred from the lower region to the higher region. That is from T1 to T7. So whenever we are switching on the heater, immediately we have to switch on the stopwatch. For every 2 minutes we have to take the values from T1 to T8 as well as the energy meter reading. So we have to find out the heat load of the system. Whenever we know how much energy we are giving to the system, then only we can calculate the overall heat transfer coefficient. So here we can observe the 4 types of reading, that is the energy in kilowatt hours, energy in kilowatts, today's date and the time of the present time. So every 2 minutes we have to note down all the temperatures from T1 to T8 up to steady state value. Steady state value is nothing but the constant values. There is no change with the previous value, that will indicate the steady state value from T1 to T8. Right? See, whenever we observe the steady state values, then we can stop our experiment. Then we have to move to the calculation part. We all know that the heat transfer coefficient formula H is equal to Q by A into Ts minus TEA. Q is nothing but heat load we are giving the system. Q is equal to P by TB into 3600 by 3200 into 1000 when we are getting the watts. And then A is the area of the particular test pipe. And then Ts is the surface temperature. Here we are surface temperatures are from T1 to T7. The average value of T1 to T7 by 7 we will get the Ts value. T8 is the ambient temperature. By substituting all the values we will get the heat transfer coefficient of the test pipe. That is nearly about